Yesterday, we started talking about linear relations. We looked at what makes relations linear as they are demonstrated on a graph. We looked at what linear relations look like when you take them from a table and plot them on a graph. If you can draw a straight line through the thing is linear. We were in the process yesterday of discussing this. We'd almost finished it, but we didn't quite get her done. So we're going to finish this, and then I've got a few examples of what it looks like for an equation to be linear. And then I will be done, and you guys will have some work to do. So, you guys said that this was linear. We went through these three. We looked at how an easy way to tell if something is linear or not is to see if it goes up by a consistent amount within each variable. So in this first one, the x's are all going up by 1s, the y's by 2. If the amount they're going up by is consistent every time, you've got something linear. This one went up by 2s, this one went down by 3s. It works. This one went up by 1s, but then all over the place. Up 3, down 4, up 6, down 8, up 4. Just kind of a mess. Obviously nonlinear. And then at the end of the class yesterday, I tossed you this guy. And you were in the process of arguing that, in fact, it was linear, but we didn't get to finish that discussion because the bell went and then you all left. So, to review the conversation we were having, you guys had said, well, these x values go from 1 to 2, 2 to 4, and 4 to 7. So the jump here is 1, the jump here is 2, the jump here is 3. And over here, the jump goes from 5 to 7, which is 2, then 7 to 11, which is 4, then 11 to 17, which is 6. And several of you were fairly firm in your conviction that this was linear. In fact, I did agree that those people were right. It is, in fact, linear. And then we lost the discussion on why that's true. So let's take a look at perhaps why. Before I start talking, does anyone who had this conviction want to continue what they were saying yesterday? Gershon, you were in the middle of saying stuff, so Emma, so were you. Do either of you want to revisit this, or do you want me to go for it? Me? Okay. Gershon, did you have any thoughts you wanted to contribute at the beginning here? You said this was linear yesterday. I agreed that you were right. Do you want to try and justify why? No? Okay, here we go. So let's look at what's going on here. Ruben and Zilkaran. This first jump here is from 1 to 2, and then from 5 to 7 we go up 2. This kind of is our baseline. Let's take a look at what happens as we go up. This one goes up from 2 to 4, and this one goes from 7 to 11. If instead I wanted to find the intermediate point here, like the point between 2 and 4, I could, instead of going up twice to get from 2 to 4, I could go up 1 to get from 2 to what value? 3. That would be going up 1. And then from 3 to 4, I'd go up 1. So I could break this jump of 2 into 2 jumps of 1. Could I do the same thing here with the y's? Instead of going from 7 to 11, could I make a jump of 2 and then another jump of 2? Yeah, I could make it from 7, I could go to 9. That would be a jump of 2. And then from 9, I could go to 11, also a jump of 2. So I could break all of these things down and say, okay, well, I can do the same thing here. Instead of going from 4 to 7, I could go from 4 to 5, 5 to 6, and 6 to 7. And I could go from 11 to 13, 13 to 15, and 15 to 17. I could break this up into 3 groups of 2 jumps. And so there is an overarching kind of more complete rule for linearity. And what we're going to look at is, and there's a particular order we choose to look at it, and we can look at it in either order. It doesn't really matter, but mathematicians decided that this was the way, and so thus it shall be. The full rule is this. Instead of looking individually if we can break things down, there's a relationship here that holds. If this, triangle y over triangle x, this triangle is a Greek letter. It has a name. Its name is delta. And it stands for the change in something. This is a fraction, so a ratio. And what this means, Gershon, put your phone away, is that if the change in y for a given jump on the y's divided by the equivalent jump in x, so if the change in y divided by the change in x is constant. The relation is linear. And I'll show you what I mean here. So I'm going to slide this thing this way. Let's look at the first jump. The first jump has a change in y of 2 and a change in x of 1. So yeah, we got writing utensil, cool. Change in y over change in x is 2 over 1 for this first jump here, from 1 to 2 and 5 to 7. For the second jump, the change in y over the change in x, that's this guy here, is the change in y goes up 4, and the change in x goes up 2. Is 4 over 2 the same as 2 over 1? Yeah, one is reducible to the other. I can divide this guy by 2, this guy by 2, and I can reduce this fraction to 2 over 1. So this jump here, up 4 and up 2, is the same as up 2 and up 1. Now if I look at this last guy down here, I don't have space, so let's go through. The change in y is 6 right here. The change in x is 3. Is 6 over 3 the same as 2 over 1? Yeah, I can divide both by 3. One fraction is reducible to the other. And because this ratio is the same for all the jumps here in x and y, this thing is linear. And this is the complete rule. If they're consistent all the way up, definitely linear. But if they're not consistent all the way up, you have to check this. See if for every jump, the change in y over the change in x is consistent, is constant. And this is going to be a concept we come back to in a couple days. So this is tables of values. We have graphs. We have a table of value to a graph. Now we've got tables of values without graphing. And now we're looking at equations. I got 4 examples here. That was a heavy sigh. I got 4 examples here. And then I will be done for the day. So to construct a table of values given a linear relation as an equation, we'll look at how we can identify them from an equation next week. But if I give you a linear relation and I give it to you as an equation without a filled in table of values, you have to pick values. Raven, I do not want to see the back of your head. I want to see the side of your head while you're looking at the TV. That TV. Okay, so you need to pick values. You choose values for x, and there are good and bad values to pick for x. We'll go over how you do that. You want to substitute these numbers into the relation for x and then solve that thing for y, something we've kind of seen before. Yes, Ruben. Is that a hand? Okay. Once you have at least 3 points, you draw, and if you can connect, you connect. Obviously, the more points you have, the better things will be, but you need at least 3. The best number to always start with is 0. 0 is always the best number. And then the numbers you pick after 0 will change depending on the equation, and I'll show you what I mean by that in a second. So, let's fill in the table of values here. Let's pick 0. I'm going to throw it right in the middle. So, remember how we substitute? I picked a value for x, and now I want to put it into this equation. To substitute a value into an equation, we replace in the equation the variable that we're substituting with a set of brackets. Then we take the value and we shove it in there. So x is now 0. What's 2 times 0? 0. Cool. So if x is 0, y is 0, and we can throw that point on the graph. 0, 0 is that point right there in the middle. And now on this one, the question for everything we're going to do here is, if I plugged in -1 and 1, like these are the next simplest numbers to do, will I end up generating somehow a fraction? Well, let's take a look. And some of this involves some mental math here. If I take 1 and I put it in here, I'm going to end up with 2 times 1. 2 times 1 is going to give me, and if I put -1 in here, I'm going to get -2. So putting in, these are the next two easiest numbers to consider, and they're not going to give me anything gross here. So let's use those. Let's say that x is -1 and x is 1. I'll give you an example of what I mean by gross. Not right now. You had lunchtime, and I'm in the middle of a lesson, so no. Now we're going to take -1, we're going to plug it in. So y equals 2. I'm going to put -1 in there, and you already said it. 2 times -1 is -2, and so our y value then is going to be -2. Likewise, if I put 1 in here, 2 times 1 is 2. So if x is 1, then y is 2. I've got three values now. Let's graph them. 0, 0 is there. -1, -2 is left 1, down 2. And then 1, 2 is to the right 1 and up 2. And does that look like a straight line to you? Yeah. That relation, this equation, represents a linear relation. There it is. I created the table of values. I created a graph. We're good to go. When you're ready, flip the page. You got 3 more. Oh my God, no questions, Raven. Yes, for you, 3 pages. There we go, same deal. We're gonna start with 0 again, and we're gonna do the same drill. We're gonna pick values for the equation, plug them in, solve. If I put 0 into this equation, I'm gonna get y equals, now that minus sign stays out front, I replace the x with a set of brackets, +1, and I'm gonna put 0 in there. Negative, and then again, remember, when you've got nothing in between here, I'm multiplying by -1. -1 times 0 is 0. 0 plus 1 is 1. Cool. If I plug -1 and 1 in here, again, I'm just multiplying by a negative and adding 1 here. So using -1 and 1 isn't going to create anything weird. So let's use those. So I got y equals, I put the minus sign out front, I put a set of brackets where my x was. Finished? Nice. Thank you very much, Dar. So if I plug -1 in here, -1 is going to be, sorry, if I have -1, it's +1. +1 plus 1 is 2. If I do the same thing down here, negative times 1 is -1. -1 plus 1 is 0. Now let's plot those points. The point -1 and 2 is going to be right here. 0 and 1 is going to be right there. 1 and 0 is going to be right there. Does that look like a straight line to you? I mean, if it doesn't, you need to go get your eyes checked. We need to improve the prescription. It's a straight line. Here we go, C. Okay, 0. We always start with 0. 0 is great. Y equals, and I substitute these things in. I write the equation. I replace my variable with a set of brackets, and then I put the value that I want to substitute in inside those brackets. And now I go ahead and do that math. 2 times 0 is, and 0 minus 4 is, -4. So that's our first point. Looking at what's going on here, if I put 1 in here, is that going to give me any sort of fractional mess? It'll be 2 times 1. That's just 2. Nothing weird there. So let's use 1 and negative 1 again. No ugly fractions. So if I plug negative 1 in there, I'm going to get y equals 2 times negative 1 minus 4. 2 times negative 1 is? Negative 2 minus 4 is? Negative 6. I'm at 2 going down 4. So let's do the other point. 2, there's my brackets, minus 4. Shove my 1 in there. 2 times 1 is? 2 minus 4 is? Negative 2. Nothing weird and gross there. So let's put some points in here. Negative 1, negative 6 is going to be down here. 0, negative 4 is going to be right there. 0 in the x, down 4 on the y. And then 1, negative 2 is going to be over 1 and down 2. Again, something that looks linear. Let's do one more. Okay. One more and then I'm done. Whether or not I let you leave is a different question. Okay, so if I plug 0 in here, 0 is always nice because, let's take a look at what we have here. We've got 1/2 is our new equation, x minus 1. So we're going to have a half. We're going to put a set of brackets down. We're going to go minus 1, and I'm going to plug 0 in there. What's 1/2 times 0? 0. And then 0 minus 1 is? Minus 1. Okay, cool. Does anyone see the point of this example? What's the problem here now? Sorry, Gershon? Yeah, we're gonna if I pick 1 and negative 1, I'm gonna have to multiply it by a half here, and I'll be introducing a fraction. As much as possible, you want to avoid that. Graphing fractions, especially on a graph labeled like this, graphing fractions is not nice. So this would be an example where we don't want to pick negative 1 and 1. Taking a look at this guy here, depending on your chosen value for x, you can introduce a fraction here. Introduces a fraction. If you find yourself at the point where you could do this, be careful what values you choose. So what kind of values would be better here? 10. Why? Because multiplying something by a half is the same as dividing by 2, and half of 10 is 5. You betcha. Is there a smaller value we could pick? We could pick 2. Anything else we could pick? 4. So 2, 4, and 10 are all what kinds of numbers? Evens. Anything even. Or any multiple, in this case, any multiple of 2 would work. So when there is a fraction, it doesn't matter what the numerator is. There are things that the numerator could show up here. If you're given a fraction, pick values for x that are multiples of your denominator. Pick, and I'll put a note in here of this, pick values for x that are multiples of the denominator. I didn't leave myself enough space. Okay, so you guys gave me a few. I heard 2, 4, and 10. Well, I'll do 2 and I'll do 10. Because we also want some negative values in here. Let's do -4. And we only need 3. Let's check these 4 values and see, or these 3 other values and see what happens. If I plug 10 in there, I'm going to get y equals half bracket -1, and I'm going to put a 10 in here. Gershon already said it. Half of 10 is 5. 5 minus 1 is 4. Marcus picked 2, I think. So let's try Marcus's value. The procedure is the same. We're just writing out my equation, putting brackets where the variable was, and I'm going to put that number in there. Half of 2 is, and 1 minus 1 then is 0. We like this. 2 turned out to be a really nice value. And I'll shove -4 in there. Y equals 1/2 bracket -1. If I put -4 in there, what's half of -4? It's not 2, it's -2. And then -2 minus 1, -3. You're at -2, you're going down 1. So let's plot all 4 of these points and see if what we've got is a line. I want -4, -3. That's going to be this guy. I'm going to go left 4 and down 3. 0, -1 is going to be just on the y-axis at -1. And then 2, 0 means I'm going to the right 2. And then 10, 4, Gershon's value, means I'm going right 10, and up 4 is right there. Do those 4 points look like a straight line to you? Straight. Diagonal doesn't matter. It's straight, not curved. I can use a ruler. There it is. Sorry? Then you've got a bigger problem. If you're using curved rulers, don't use a curved ruler. Okay, I'm done. Comments, questions, concerns? Okay, Dilkaran, Ruben, I don't know what's going over there with Marcus and Hayden, but just stop talking to them for a second. No, but no conversation needed to occur across the classroom. I'm almost done. Here we go. Here's what I want you guys to try. I want you to do 4. I want you to do 5. I and I. You can skip I. I want you to do 6, 7, 9, and 10. Now, just so you're aware, if you flip the page, I have a whole page of empty graphs. You can use those. There's a few questions in there that require you to graph. You can take a look at those. Question 6, ladies and gentlemen. Liam, stop talking, please. Jackson, stop talking, please. Question 6, guys. Well, 5 and 6 looks like this. 5 says, does each represent, looking at each of these 4 tables, does each one represent a linear relation? You don't have to do part 2, or II. Part 3 says if the relation is not linear, explain how you know. Question 6 says, for any of these down here that are linear, graph them. Now, there will be one, for question 6, one will not fit. Do not graph. One, extend the table. It'll fit. And then there is another one that you don't have to do anything to. So 3 of those are linear. There is a 4th one that is not. Prove it. And then I want you to do 6, 7, 9, and 10 as well. So there's your homework. You have the rest of the block to do it. May the force be with you. want to see what you've done. That's what I want to see. See if you made an effort to do all the things. No, this was just yesterday. Like, all I want you to do is have you written down the lesson we did today. Yes. Sweet. If we would like to do the homework, you need to hold on. You didn't write down what I assigned. Write down what I assigned. Write it down. Okay. Yes. I remember you. Okay. Okay, gentlemen. How about you finish the stuff we did? Why? You don't write down the lesson stuff that we do. There is so much more on my page than there is on your page. Yes. Go down and work at that. Okay.
Where's our $4? I don't know. This is a pocket design. Oh, shit. You're like a tomato right now. Marcus, bro. I didn't do anything. He looks like you, boss. Marcus talking today. No, bro. I swear to God, no. Wait, is this Starlight? Your face is so red. Marcus, you gotta go off the game. You already told me. Marcus, you gotta go off the APD. What? Marcus, I'm thinking that about this. I swear to God, no. I'm thinking that about this. Marcus, I'm thinking that about this.
Okay. I have a task for you. It hasn't been given already. Correct. Incorrect. Yes. It's better to call something special. Is it not? Yeah, no, but special is offensive. Not that you say it sarcastically. Okay, get to it. You cannot go to the water. So you've made reasonable progress on your homework.
Isn't that like illegal?
I don't have to let you go in.
My body.
No, you don't stop when you miss it.
All of these jumps are one.
So I want to put on like
So this is 2 over 1 is 2.
I'm assuming he does not like that.
There are teachers who have a limited number of bathroom breaks you're allowed to take per semester. You get like 3 per semester. So you save them until there's actually an emergency. Yeah, there's another math teacher.
Not even 2 per month.
Who will be like, no, he's did the semester. And he has a class list printed on a clipboard and he just makes notes about it. Well, think about this. Think about this. You have, no, he's actually a great teacher. You're not in any position to talk about doing or no, you do nothing. You do nothing all semester. You've done nothing all semester. Get to it. First period. Second period. Till lunch. Third period. Fourth period. For 40 minutes. And you don't have to. If being is important, don't gossip. If gossip is important, don't be. Then don't make my class time. Is what that teacher would say. Obviously, I don't have this rule. She shall remain nameless. It's not Chu. It's one of the other four. Could be Abe. Could be Myers. Could be DeVries. DeVries has rules about being late. That dog goes, he locks his door. You show up after the dog, you're not getting in. And he makes you wait. And he yells at you. He lets you. Okay, so then you fail in class. Okay, that's cool. How about you just show up? Just show up on time. And that's going to be a regular thing for you. Then yeah. But he teaches grade 11s and grade 12s. The students who want this stuff. That's the work. You're in this class? Yeah. Don't be late. Don't be late. I mean, obviously you have an excuse, show it. But in general, don't be late to the race class. Yes. How do you know? There you go. That's it. Okay, get to work. So Karan, get to work. Dale, Karan, get to work. Why are we swearing in German? Just get to work, guys, on the math that I have assigned Dil Karan, Ruben, and Brielle. So the question is, which German flag? Germans have some cool flags.
I know they do.
That Iron Eagle, that's a badass
I
emblem.
remember the old cheer logo.
They had a logo for about 10 years in the early 1900s. Not a great one. But the Germans have some cool flags.
Might get you in some trouble.
Yeah. Yeah, might get in some trouble. One of the flags that they adopted, yeah, early 1900s.
It's not great.
Not a great flag. But that Iron Eagle and Iron Cross.
I have a question. Autopilot. Autopilot.
And then wear a white clothing and was running up and down the street doing cake.
Sorry, when did you get out of here? When did you get out of jail? Money line. When did you get out of hospital? No.
Oh, I have some.
See you later.
Yes. Linear in math is different than just doesn't make a line. Like this line in math is straight. If it's curved, no, it's not. So this one, not linear. Because it's curved. This one, I couldn't draw a straight line through here, so it is a line. It's linear.
Yeah, that's not how it works.
Linear is two straight lines. This one is one that we already wrote yesterday.
My board doesn't have to.
Even though C doesn't are linear, like straight line, straight line, straight line. The whole object, that's one straight line. Not bent in the corner.
I don't have the line. What? Yeah, India. Oh, wait, no. Oh, not India. Why does it matter? Like the most popular. The Godspeed.
Well, you see, I'm not going to say no, that's why it's not linear. It just makes it different when you grow up. One week that if you adjust your table. One will line, one will fit nice. This is the one where you can adjust. This one goes up, one, up, one, up, one, up. Oh, how to work backwards? Hey, language. Yes, thank you. How much do you want it? But describe each of these words. X is well, Y is well, 7. Like, but that one you want to don't do. Definitely do 3. Hey. No, next class. Also, stuffed animals hold tannerite. Stuffed animals hold tannerite. If I know the forest, that's the tannerite. Tannerite is a really stable compound that when you shoot it, it explodes. But you can hit it with a hammer, like it's safe. Until you shoot it. At varying amounts, like my stag, so like my bachelor party or whatever, was me and 10 other dudes And we went up into the bush way behind Nation. I have a collection of firearms. My buddies have their various collections of firearms, and we spent almost 4 hours blowing stuff up. And then we went to dinner, and then we went to, and there was an intermediate point where they made me wear ridiculous things in Walmart. And then we went to play board games. That was a good time. 6 hours of shooting right at the beginning. Yeah, 100%. It's very good. So conservation officer came back to start with bullets. That's where we would go. I've wanted to shoot a crossbow so badly. Crossbow pretty cool. Okay, but not related, Charlie, to what I want you to do now. Neither is your stress fight. It's more related.
Oh, that's your 17. Really good. Oh, it's actually. This keeps them. On the next page.
Don't worry about it. You do you, man. Great question. I think it's 115. It is 115. Yes. Well, each one goes up by 1, and then on the left, and on the right goes up by 2, 4, 6, 8. You tell me. Use what we did in class. Is it linear? Prove it or not. And the ratios are going to be different. Like the change in y over the change in x for the first two is going to be 2 over 1. And then it's going to be 4 over 1. And then it's going to be 6 over 1. So because that's different every time, it's not linear.
On the graph section. What? Do you even know what you're saying?
Recently? Not since the last one. There hasn't been a new one. There was the last piece of news I saw in the last couple days. We've done a whole bunch of those confiscated guns, already confiscated guns. I'm shipping to Ukraine. Well, that might be the one you saw. And I don't totally disagree with some of the stuff that they have. Well, even some of the semi-automatics will do that. Like, you're not going to hunt with those. You don't need that for self-defense in the bush. Unless it's like, especially some of those like the chamber for obviously military rounds, not necessary. I mean, and if you really, people who like hunters who really care, I've seen hunters shoot as fast with a bolt action as a random person could do with semi-automatic. Good hunter wouldn't need to. And those are the people who should be allowed to keep their guns. So if you think, I know, don't get me wrong, those semi-automatics are a lot of fun. Like I've used the SKSs and the, it's a great time. They're not necessary.
This is my,
So you're not really sure.
massive 4 points.
There was some like record moves.
Yeah, there was a
that one.
Yeah.
I missed the first page.
Yes. Yes. For a first vehicle?
Depending on like.
Oh, you're one of those guys. See, there's
Yeah, one of those guys.
either you're a diesel guy or you're like an off-road guy.
Yeah, no.
You get like late 80s, early 90s.
The older ones, they actually use it with diesel.
My wife's a fairly disturbing shot.
Yeah, that's like my whole family.
So I'm expecting her to be as really enough as she is. But she's way steadier with a gun than
Oh, you're ready like that.
My whole family.
Odie?
Are you ready like that?
Am I gonna post the videos? Yes, I am gonna post the videos. I have a stack of videos. That's when I stopped posting videos. I have not posted videos in couple. I have them. They're recorded. When I ripped into a couple students.
I think you have a no card. You have a no card.
Which one are you referring to?
Oh,
Which time though?
No, the one.
Some people, it's a great way to post secondary teach or my cousin went in the military, he was in the army. He was a supply tech. Served. He came back really screwed up with alcohol.
I'm so smart.
But I've known some people like my sister worked with a couple ladies who were former Canadian trainers. Fine. They served time. They were and driving the tank. They were okay. I know I've known some people who do helicopters. I went to high school with joined the Air Force. Oh no. He was in the Air Force. He's a Army parachuter. I've noticed some people who've done it. Depends how you feel like what you see me do. Yeah, did you get the fly? You can get one on the line.
But
Yeah, you almost certainly get the fly.
it's not quite the same as.
What a thing.
Yeah.
And we're done in the fall.
For now.
I don't see us going back then. The military can do a lot of good things as far as like a career path. It can be really good for a lot of people. My cousin who joined the military, he was And the military straightened him up. He was a mess. Went into the military, gave him discipline, gave him direction, gave him confidence. Also went to trauma. But it didn't want to go into it too. No, the military's military is certainly something to consider for a lot of people. Yes.
I know what to do. I know what to do.
What do you mean? For which one?
Getting ready again. He's getting ready again.
Which one? They give you an equation. They give you an equation. And they give you values. All these values in the equation. That's all you're doing.
Do it. Do it.
That's what this equation means. Multiply all the x's by 2. This one is all the x's added to. 1 plus 2 is? Yeah. 2 plus 2 is? Yeah. 3 plus 2 is? No. 3 plus 2 is? Yeah. 4 plus 2 is? Because you're taking all these values, you're plugging them into that equation. So this one says you're multiplying by negative. That's all you have to do is just plug it into the equation, and it spits out the y values. Only the ones that are linear. Yes, I've taught it in 3 other schools. 2 other schools. After doing it.
That's like
When they teach where? When they teach MEI? I taught in MEI in 2012. Sorry. 2013. Actually, I have my yearbook over there, I can tell you.
And then he came here in 2016.
No, and then I went to Bakerview for 2 years. And then I came here. My fall 2015 was my first year. Sorry? 2015, like fall 2015.
Oh, wait, did you teach Chase?
I taught Chase Claypool. He was in my psychology class.
Set a screen on me. Set a screen on me. Bro, I will take a charge on you. Set a screen on me. I'll take a charge.
Is that a threat?
Promise.
Set a screen.
Okay, it's 1:11. Bells are on 2 minutes back up here already. Don't leave. Have a good weekend. When the bell goes, get out of here.
I'm going to Mexico.
You're go pretty far now. There's places up behind Hope. That's still allowed. Decommission logging on.
You took a picture.
Marcus, fingers not out of box. Fingers not out of box. Where's the screen?
Yeah, that's all you have to do. I think those missions are right there. I love right into that property. If you can adjust your desk count to match what Real just did, that would be preferable. So, yeah, that. Yes. Try to pull that desk back.
Thank you, thank you, thank you, lad.
Thank you.
Can I get one?
But open it up a little bit. Yes, you may.
Thank you. Me too.
One.
What do you want practice?
One. One has to. No. One more block.
That's what I tell myself every day.
There's only one more block.
Yeah. It never feels right. Have a nice day.
See you later, Charlie. Hey. C, K. Ay, ay, ay. Okay. There we go.